Hi guys, last section of chapter 2. Okay, this is it. We're going to just apply the trig that we learned to some situations, some real world applications. One of them is involving the word bearing. Okay, it's used a lot in navigation. All right, and when we say bearing, we have to understand that the bearing is measured in a clockwise direction from due north, not our usual, the way we've been doing it from the positive x-axis. Okay, so when we say a bearing of 32 degrees, that means from the north in a clockwise direction, I'm sailing on 32 degrees or moving on an angle of 32 degrees from the north. 164 degrees, a bearing of 164 degrees. This is how you'd have to draw it. From north, 164 degrees. A bearing of 229 degrees, we would go 90, 180, and a little bit more. Okay, a bearing of 304 degrees, again, clockwise direction, 180, 270, and then a little bit more to 304 degrees. Okay, that's how many degrees from due north. So for example, if I have this problem, radar stations A and B are on an east-west line. Okay, let's say this is A and this is B. Okay, there's my radar stations, and they're 3.7 kilometers apart. Station A detects a plane at C, letter C, on a bearing of 61 degrees. So I have to realize that that 61 degrees was from due north because they used the word bearing of 61 degrees. So I'm going to open 61 degrees and show that I saw a plane. That's where the plane was flying. I'm not sure where C was, but the plane is on a bearing of 61 degrees. Station B simultaneously detects the same plane on a bearing of 331 degrees. Okay, so from north, right here at B, I'm going to have to go 90, 180, 270, 331 degrees. Okay. Does that look about right? And that's where they see them. So since they saw it simultaneously, we can pin down right here is where that plane is flying, right? Right there. So what's the question say? Find the distance from A to C. Okay, so this is the distance we want from A to C. Well, let's see. If this is 61 degrees, okay, then this that's left over would be what? 90 minus 61. I mean, I'm on the east-west line, and on the north, that's a 90-degree angle right here. Okay, so this is 29 degrees. If this was 331 degrees, then I can figure out what this is, can I? 331 minus 270. That's 61 degrees. I guess there was another way I could have told that, huh? Oh, well. Okay, so let's find out what angle C is. That's a 61. That's not very clear, is it? Sorry. 61 degrees. So 61 plus 29. Oh, this must be a 90-degree angle up here. Yay. Once we have a 90-degree angle, we just have a triangle. This is what we've been doing. It's a little bit tougher to set up because of the word bearing. I know that's going to be a little tricky. But basically, if I want D, okay, there's several ways to find it. I'm going to use the 29-degree angle, okay? And I'm going to say that I know that the cosine of 29 is adjacent over hypotenuse. Somebody else might have been like, yeah, I'm going to use 61 because I know that the sine of 61 is opposite over hypotenuse. Okay, so some of you are going to take 3.7 times the cosine of 29. Some of you are going to take 3.7 times the sine of 61. You're both going to get the same thing, right? Let me pull up the calculator. Yeah, I don't know if you can see it. I'll move it down a little bit. Okay, so I'm in degrees, good. Some of you are going to do 3.7 times the cosine, what did we say, 29? And you're going to get that. And others of you are going to take 3.7 times the sine of 61. And both of you, all of you are going to come to me and say, hey, the length is 3.2, just 3.2, right? It didn't tell me what to round to, but I noticed that everything's in 2 significant digits. So I'm going to have my answer be 3.2 kilometers. Okay. Everybody all right? 3.2 kilometers is the distance from A to there. Whoops, I'm sorry. Whoa, hello. Stop. That's my fault. Okay. This is another way, heaven forbid, we have to have different ways to express bearings. Okay. The second method starts with the north-south line and uses an acute angle to show the direction either east or west from this line. For example, I tried to show you several of them here. Usually if you just see the word bearing 42 degrees, then this is what it is. But sometimes they'll say north 42 degrees east. What that means is start north and go 42 degrees in the east direction. Okay, that's what N 42 degrees E means. People must have been getting confused with the 1 degree measure or something that they came up with in navigation. This is developed later. Okay, and now I think this is a little bit more common. You start north and go 42 degrees in the east direction. Okay, that's what this means. This one, you start south and you go 31 degrees in the east direction. Go 31 degrees toward east. South 40 degrees west, you still start south, but you open 40 degrees towards the west. North 52 degrees west, you start north, but you open 52 degrees towards the west. Okay, it's a little confusing. I do recognize that it's a little confusing. Sorry about that. Okay, so I think we have an example that has that with it. Okay, so read through that. Okay, a ship leaves port and sails on a bearing of 42 degrees. I'm just going to say this is my port. On a bearing of north 47 degrees east. So, okay, might as well just said 47 degrees. And there's my little ship. It then turns and sails, south. Okay, so I'm going to draw a little, let's just say I was here. I don't know where I was. But now I'm going to go south 43 degrees east. So, okay, I was here. So I'm using south as my place to start, and then I'm going to open 43 degrees east towards the right. East is towards the right. So 47. What is that? 43. Okay. If the ship's rate of speed is 22 knots per hour, find the distance that the ship is from port. So I'm looking for this distance now. Okay, here's the port. I left on a bearing of 47 degrees northeast. Okay, I got to a certain point, I don't know, I turn and sail on a bearing of south 43 degrees east. Okay, so 43 degrees east of south. Okay. Well, gracious sakes, I need to find out some angles here to see if I even have a right angle anywhere. Okay. So, oh, can we use a little bit about, what's it called? Parallel lines cut by a transversal to see that this, if this is 47, its alternate interior angle is also 47. We could look there, right? So 47 plus 43, there's my 90-degree angle. Thank heavens. So D is actually my hypotenuse. I do need to know how long these sides are, and that's where we can use what they gave us. Okay, distance equals rate times time. So if I'm going 22 knots per hour for 3.5 hours, I can figure out the distance, right? I'll have to take 22 times 3.5. 22 times 3.5 and get 77. And then in the other place, I went for in the other direction, I went 4 hours. I might as well do that while I have this up. 22 times, 22 times 4, it's 88. So 77 and 88. Okay, get those distances. So here's where I was traveling along for 3.5 hours, going 22 knots every hour. We said that was 7. And then I turned and went this direction for 4 hours. So that's 88. There we go. Let's use a little Pythagorean theorem. Since I don't really, I guess I could use sine or cosine as well, but I'd have to figure out these angles. I might as well, once I have two sides of a right triangle, I usually just use Pythagorean theorem. So 77 squared plus 88 squared. Well, we get whatever we get. And then we're going to take the square root of that answer. I usually go square root, and then I don't feel like typing that in. So I can hit second this negative sign, and that gives me the answer. 116.9. Looks like everything's in two significant digits, though. Right? 116.9. So what do you think? How are we going to say that answer since everything's in two significant digits? I would be fine if you'd say 116.9, but they actually have 120 miles as that distance. Okay, because we can only have two significant digits. That's how basically, from what we learned last time. Okay, 120 miles. It was actually whatever it was, 116 point something, but we would have to round it to the nearest way that we could write two significant digits. Okay? All right, let's look at this example. We're done with the bearings now. So I think I'm just going to put the work up here and so that you can see it, so we can be done in one video. Okay, so basically I just took the theta over 2. I only know half of theta. All right, I can only use half of theta because then that's the only way to get this right angle. Okay, so I just set up the equation that the tangent of half of theta is b over 2 over d, because that would be opposite over adjacent. I took d times tangent of, I put in the theta they gave me, 1 degree, 23 minutes, 12 seconds. And over 2, of course, it says theta over 2. So then I multiplied both sides by 1 over the tangent of that. Stuck in 2 for b. Oh, that's nice. 2 over 2 is just 1. So that's why then I just typed in 1 over the tangent of 1 degree, 23 minutes, 12 seconds divided by 2. And we get that answer. 82.63. Okay. How much it would change for 1 degree more? I simply would put in 13, not degree, with seconds. I put in 13 seconds instead of 12 seconds and then subtract those differences. Okay, see you in class. Bye.